Polar coordinates. Definition of polar coordinates. Polar coordinates give a location of a point by describing the distance from the center and the angle from the positive x-axis. So to graph a point using polar coordinates, first we would figure out how far it is. This is called the pole. And we would describe its angle from, this would be called the polar axis now, but you can think of it as the positive x-axis. So we would go out and around, out and around. Some people would argue that this makes more sense in some real-world context, more so than the coordinates that you used to do. I wouldn't give you the latitude and longitude if I wanted to tell you how far away, let's say Columbia is from Washington, D.C. Here's Columbia right here. I might tell you that it's, oh, well, here's our scale at the bottom. It's like 30 miles-ish northeast, or I might even say north-northeast. So I'm telling you how far away it is, and then I'm giving you a direction. We use that kind of language all the time. Polar coordinates are also used to graph, this is a microphone pattern. If you're familiar with different types of microphones, these are called cardioid. You might notice they make something that kind of looks like a heart. And we'll learn how to graph cardioids as well. That's another application. You don't see it as often. And their polar coordinates are used in radars. So if you look here, we have circles of different radii. We go 3, 5, or 2, 5, 8, 11, 15. And then we would be able to kind of describe the angle around something would be. We might go up like that. To graph a point in polar coordinates, we would either use a graph that's based on degrees or a graph that's based on radians. Be prepared to look at both. So you might want to review some of these common relationships here. The ones that we use a lot, pi over 2 is 90, etc. Having your unit circle out might not. So I could give you a point. Let's do this in radians. I'm going to give you the radius and then the angle, how far out and how far around. So if I gave you a point 2 pi over 3, that would be, we would go out 2 around pi over 3. So there would be my point. Maybe I'll say B is something like 1.5 and 7 pi over 6. So I'd go out to the 1.5 radius, and then I would work my way around following that circle until I got to 7 pi over 6. So point B would be there. So naming the coordinates of a polar point, we're going to do the same thing. We're going to label first the radius, then the angle. So let's say each one of these, we'll do it in degrees right now. Let's say that's 30 degrees, and each one of these is 1. So point A, I would give as 1, 30. I could also think of it as not just 1, 30, but I could keep going around the circle. It could be 1, 390. So I could keep adding 360s and keep getting ways of describing where point A is. For point B, it has a radius of 3, and it's at 300 degrees. Again, we could add 360 to that. and point C would be at 3, 180. Point D all the way out at a radius of 5. This is 180, add 30 to that, and we get 210. Let me know in class if you have questions on this. We need to be able to go back and forth. You need to be able to plot the point and find its coordinates. So not only that, but we need to, eventually we're going to convert between them. We'll probably do that on the second day of class. So if I was given a point in a polar coordinate, so if I was given this point here, let's call that A, and I wanted to give its points in rectangular, so that's x comma y. That's sloppy. I would have to break it down into an x and a y component. So I would use the fact that it forms a right triangle. And I know this hypotenuse, and I know the angle, so we could use sine and cosine to find the x and the y, or cosine for x, sine for y. If I'm going the other way, let's say I'm given my x and y coordinates, here's x, here's y, I can use the Pythagorean theorem to find the radius, and I could use inverse tangent to find the angle. So eventually we'll take this beyond just plotting points, like you would have done in like middle school with rectangular coordinates, and we'll go to graphing equations. So I use a little comic strip. So I thought it was kind of funny and illustrates this point. I want to just draw your attention to what the polar bear says. He says, igloos make a lot more sense in spherical coordinates, though. To ruin the joke a little bit here by explaining it, what that means is certain graphs are easier to do when we're using polar coordinates or spherical coordinates. For example, if I write out the equation r equals, let's say, 2, in rectangular coordinates, if we just had like y equals 2, that would be a straight line. In polar coordinates, if I say r equals 2, that means no matter what the angle is, the radius will always be 2. So you would get a circle. So this is the equation of a circle in polar coordinates instead of x squared plus y squared equals 4. Alright, that's it. Make sure you take notes and make sure you have some ideas of some questions that you have. I will be starting off by doing plotting points, and then we'll move on to converting between rectangular and polar.